Welcome to Brain Vision.
Hello everybody. So we're going to work on this problem where we're given a laser that produces a light of 625 nanometers, right? And an ultrashort pulse. Based on the minimum, what is the minimum duration of this pulse if the uncertainty of the energy of the photon is approximately 1%? So this, with all the uncertainties, it's screaming at you to use the uncertainty principle. And since they give you the wavelength and they're asking about time, you just simply want to use the energy time uncertainty principle. So that gives you your uncertainty in E times your uncertainty in time. It's going to be greater than our H bar over 2, right? So what they're trying to, since we're looking at this, they're asking the minimum uncertainty, the minimum duration based on the minimum certainty. So if we just solve for t, or delta t, it's greater than h bar over 2, right? So as long as t has to be greater, so this would give us our minimum based on our delta E right here, right? We also know that our E is equal to hc over lambda, right? And then our uncertainty would just, for delta E, would just simply be hc over lambda times that 1%, right? Which would be 0.01. So if we were to plug that back into our equation over here, delta t is h bar lambda over 2 hc times our 0.01, right? That 1%. But so you could just plug in numbers here at this point, but I like to, I don't like working with h or h bar. They're very, very small, minus 35 numbers. So might as well just convert our h to an h bar and cross them out, right? So in that relation, h equals 2 pi h bar, right? Not too bad. So we'll go to the next page and just show that and finish this problem up. So our delta t now, or uncertainty in time, is going to be greater than lambda over 4 pi c times 0.01, right? Our lambda was given, right? It's just 625 nanometers, which is 625 times 10 to the minus 9 meters, right? You always want to do this in standard units. And then our c, remember, c can just be abbreviated 3 times 10 to the 8 meters per second, right? That's the speed of light right there. So you can see just by units, we want it to be time. Clearly, our meters from here and here are going to cancel out, and our inverted seconds on the bottom will come up. So this is going to be in time, which is good. We want that. And when we multiply these all out, we get delta t is equal to 16.6 times 10 to the minus 15 seconds, or 16.6 femtoseconds. So this right here now, right? Let's just talk about this for a second. This is the minimum time that a laser of this energy, right, or this wavelength, and an uncertainty in energy of 1%. This is the smallest amount of time in a laser pulse that we could make. So that's what that means, right? Okay.